3 here and see what happens.
First, measure first. I need you to double check yourself.
So the second equation for solving perimeter is
2 times length plus 2 times width.
Welcome to the elementary edition of Count on Us. I'm Sherry Sternberg.
I'm Miss Shirey.
And we are here to help you with your math homework. It's a rainy day outside, but it's bright inside because we're working on math.
That's right.
What do we have going on today?
We have a lot going on. We have a word of the day challenge that we're excited to tell you about. I don't know if you're familiar with our word of the day, but here it goes. There is a hidden word underneath this piece of paper, and it has to do with math. And we want you to try to figure out what it is by asking us questions using your knowledge of math to figure out what the word is. We also have
The old standby, challenge 24. You know that you have 4 numbers that you need to work out using, look at my earrings, addition, subtraction, multiplication, or division, or any combination, to get these cards, these numbers, to equal 24. So we want you to copy down the numbers. So while you're waiting patiently on the line, you are working on these. We also want you to be good listeners, because if one caller calls in with a solution, there are multiple solutions to cards, so you can give us a different solution, but not the same one.
Right.
So copy them down. We'll start with card A. Card A. You have a 5, a 4, a 5, and a 1.
correct. Card B, 4, 4, 9, 1.
And we know this is 9 because?
It has that red mark. It's filled in.
All right, so then card C, these are not 9s. 9s are filled in heavy. These are 6s. So we have card C, write it down. 6, 6, 2, and 4.
And card D, 3, 6, 2, 7.
And you know what? This isn't just for students. If you have adults out there watching,
That's right.
feel free to work these out, because it stimulates the brain. And as you get older, you got to keep that brain stimulated
right.
just as much as when you're younger. So let's say they come up with a solution. How do they let us know?
Oh, you call in. Just call us our number, 301-772-0080.
All right, so that's the number, but there's other ways to reach us. Some of you might be watching us on cable channel 96. Is it Verizon 96?
It's Comcast 96.
Comcast 96, Verizon 38. You might be streaming watching us right through your computer. And note, if you're doing that and you're trying to call us, that there's a little bit of a delay in the audio. So don't think we're not hearing you. It's just we're hearing you a few seconds later. And then the email corner. What can they do with that?
You can email us at cou.pgcps.org. All right, and we're here taking your emails, your phone calls. I know it's rainy. I know you're inside. You must be working on your homework.
We hope. And if you don't have homework, because with this fast testing going on right now at some schools, sometimes teachers don't give you homework when you're doing those fast tests. So you have some options. Work on our challenges, or think about what you might have had some difficulty with on that fast test, and we're here to help you. So give us a call, again, 301-772-0080. Here to help you here with your homework, our math challenge, challenge 24, and our word of the day.
That's right, word of the day.
All right, so do you want to show them how to do a challenge 24? I know a lot of our listeners know how, because we do it regularly, but some of them do not.
Okay.
So let's do a card B, since it's a 2 dot.
Okay, that means it's a little bit harder.
Hopefully.
All right, so 4, 4, 9, 1.
All right. 4, 4, 9, 1. And we're talking about math. We talk about patterns.
That's right.
So do we see any patterns in the numbers?
I don't know. What kind of patterns? Well, we would definitely want to get down to making some factors that equal 24.
Okay, that would be a good way to
So
start.
I always think about the factors like 6 and 4, 8 and 3, 2 and 12. If I can ever use these numbers to get down to those 2 numbers, I know I can always multiply them together to make 24.
All right, so I'm seeing a 9 and a 1, which is a 10. A 9 and a 4 would be 13. 13 minus 1 would be a 12.
Right.
But then I have a 4. 4 times 4 would give me a 16. What if I added the 10 to that? That would be a 26. So see how I'm doing a lot of mental math in my thinking, trying to put these numbers together. 9 minus 4 is a 5. Now, I did hear you say that one of the factors was a 6 and a 4.
Yep.
So look what I'm thinking. 9 and 4. 9 minus the 4 gives me
5.
the 5. But I need a 6. I have a 1 here. So 5 plus 1 is going to give me
6.
my 6. So now I've used my 9, my 4, and my 1.
Right.
Look what I have left.
A 4.
A 4 with that 6.
Yep, that's all I need.
6 times 4. And when that happens, this is what happens.
Oh, yeah.
Because we're going to ring that bell if you get that 24.
Yep.
That means you've met the challenge. Ms. Sternberg has met the challenge. Then what we would do is write your name on our little piece of paper right here. And then we will put your name in our apple. And then, look at these sequences. After your name goes in the apple, you keep watching the show. Other callers call in. Depending on how many we get more names in the apple. And at the end of the show, we pick out a name, and that person becomes the winner. Right now, even though I got the challenge 24, I'm not going in the apple, but one of you might be, and we have a caller on the line,
do.
so
We
that
have a
caller
caller.
might be the one.
Hello, welcome to Count on Us. What is your name?
Hello?
Hello.
Hi,
Hi, what is your name?
Cheyenne.
Hi, Cheyenne. Welcome to Count on Us. And what school do you go to?
Cherokee Lane.
Cherokee Lane.
Cherokee Lane.
Cheyenne from Cherokee Lane. What grade are you in?
6.
6th grade. Oh, wow. Okay. What kind of problem do you have for us tonight?
Percentage.
Percentage. All right.
It's 60. Find what find what is wait. Oh yeah. What is 64% of 16?
64% of 16. Okay. 64%. So 64% of 16. All right. So how did your teacher tell you to figure out these problems? Did she give you a strategy?
He said to turn the percentage into a decimal.
That's right. And what decimal would 64% turn into?
6400.
Right, 6400ths.
And if I can do one thing before we do that, or while you're doing that, what I like the students to do, Cheyenne, is to have an idea about how much we're looking for before we do this. So, you know, what's a common percentage that we're familiar with? We're familiar with, obviously, 0% is nothing, and 100% is how much of 16?
All of it.
All of it. So 100%, 0% we know is none, and 100% we know is the whole thing, all of it. I like the way you said that, 16. So what would half of that be? What would 50% be?
8.
8, exactly. So this is what I'd like you to do when you do your percentage problems. Think about, 0, that's nothing to think about. The whole thing is 100% at 16, or whatever number you're dealing with. Figure out what the half is. If half of the 16 is 8, is the 64% going to be more or less than 8?
More.
More, because 64 is more than 50%. Now you're in a point where when you do this multiplication, you have an idea of about how much that number is going to be. You know it's going to be less than a 16. You know it's going to be more than the 8. And what's right in between? Think about your quarters. 1 quarter is how much?
25.
25%. 2 quarters is 50%. 3 quarters is?
75.
75. So what would half of the 8 be?
4.
4. So I'm kind of now making a table here, an input-output table. 0, 25, 50, 75, and 100. And we'll call all of these our percents. And again, whatever number you're dealing with, put that on your table and think of it as money. So you have 16 here. Half is 8. We know this is 0. Half of 8 is 4. And then if you add your 50 and 25 together, you're going to get your 75. How much is 8 plus 4?
12.
12. So now, 64%, we're even isolating it even more. We know it's going to be in between 8 and 12. All right? You see, does that make sense to you, Cheyenne?
Yeah.
All right, great. So this little extra step takes us a couple minutes, but it puts us in the ballpark where we know we're looking for a number greater than 8, less than 12. Now let's see where Miss Shirey takes you.
All right.
Or you take Miss Shirey.
You take me. You told me that 64% is 64 hundredths. You are right. What do I do next?
I forgot that part.
Okay, when it says 64% of 16, this of right here is telling us a certain operation. It's telling us to multiply. Do you remember that part?
So You have to multiply 16 by 0.64.
That's right. 64 hundredths.
I remember.
And all you have to do is multiply the two together. All right, are you ready to multiply with me?
Yeah.
All right, let's 6 times 4.
24.
6 times 6.
36.
Plus the 2.
38.
38, very good. All right, now I'm finished with the 6. Now I'm going to multiply by the 1, but that's really a 10, so I need to leave my placeholder, right?
Yeah.
Okay, so 1 times 4.
4.
1 times 6.
6.
Great. All right, now I add my two partial products together. 4 plus 0.
4. 12.
12, regroup. 6, 7, 8, 9, plus 1 more.
10.
Right. Now, my answer is not really 1,024, and we know that wouldn't make sense because we already did our little chart over here, our little estimating. We still have our decimal in our multiplication problem. Do you know what you do next?
Yeah, you count how many numbers are behind the decimal.
Yeah.
It would be...
Cheyenne, wait a minute. Before you count, use your number sense. Because it makes you so much more comfortable with numbers when you can use number sense. If we already said your answer is going to be between 8 and 12, where would the decimal point have to go to make sure that your number is between 8 and 12?
The 10 and the 2.
Exactly.
Right.
And then use your decimal point to count and check. But first use your number sense so you know you have a feel for numbers. Because when you're out at the store and you want to figure out a percentage about how much something's going to be, you're not going to do all these steps and start counting places for your decimal point. You want to have a good idea just because you understand your numbers.
All right, so let's check. Let's start here. Let's count back 2. 1, 2. You are absolutely right. That's exactly where the decimal goes. So how do you read the final answer, Cheyenne?
10 and 24 hundredths.
Very good, very good.
Excellent.
And it fits right in here.
Excellent.
Right in our chart, so we know we're correct. All right?
Make sense, Cheyenne?
Yeah.
So I would love to be a fly on the wall in school when you do these kind of problems and see if you really do this extra step we showed you. Because students don't like to do that extra step, but it guaranteed that you were in the ballpark, that you used your number sense. Because as I said, when I'm out at the store, I do mental math, which is what this helped me do. I don't do all this multiplying out and carrying and regrouping. I mean, we need to have that skill, and we can also use calculators to check it. But when I'm at the store and I want to do a quick idea of what percent something is, when I'm leaving a tip at a restaurant and I'm thinking 20%, I know how quickly I can do 10% because it's the first 2 digits, and then I double it. So we need to learn some tricks to be efficient mathematicians with our mental math. Okay, Cheyenne?
Okay.
That was my soapbox for today.
That
I'll probably
was
have
great.
another one coming up, but
No
for
problem.
now,
That was great.
we wrote your name. It's going in the apple, and we want to give you a chance to get your name in the apple a second time by doing one of our challenges. Are you ready?
Yeah.
All right, which one would you like to do?
Challenge 24.
Which,
All right.
which letter?
It's 9441.
9,
All right, now you have a different solution from the one that I just did, right?
Yeah.
All right, 9441. Let's see what you got.
4 times 4 equals 16.
All right, that's different than mine. 4 times 4 equals 16.
16 plus 9 equals 25.
Oh, 16 plus 9 equals 25.
Oh, look out.
And 25 minus 1 equals 24.
25 minus 1 equals, when you hear this bell, you know you got it. Equals 24. Excellent job, Cheyenne.
Very good.
And I love that you showed a different solution than the one I came up with. It's great that people, students and adults out there, I know there's a couple of adults watching us, that there are multiple solutions, which shows that we can be flexible in our thinking and come up with different answers. So Cheyenne, 2 times you are in here. Excellent job. Tell your friends to give us a call, and you can also try and call us back.
Thank you,
Okay.
Cheyenne. That was great. Another way, I was really impressed.
I was too, and actually I should keep this on a chart so we have this written down. But I don't want to leave Cheyenne's problem. I want to do another percentage problem
Okay.
and do that step that I hope. I teach my students a lot of those skills to help you get somewhere in an efficient way, but sometimes they don't, the think bubbles and the estimation before you solve a problem. And students don't like to do that because they just want to get it done. But I'm telling you, it really, as you become an adult and use your math skills for real life skills, not just for book skills, they're very beneficial. So let's take another problem like that. Let's take an off percentage, like a 37%.
Oh, 37 would be great.
37%. I want to know 37% of, let's say, 48.
Ooh, 48.
All right.
Okay. All right, great.
So let's see how we do this. We said a couple of steps. 38% is it's not a friendly, that's a good word for it. It's not a friendly percentage.
No, it's
Our
not.
friendly ones, and we said if we start with 0 and then use our quarters, 25, 50, 75, and 100, and these again are all percents. I want to put my 0. There we go. So we know that the 48 goes here, and we know that the 0 goes here. All right. So to get the 50,
24.
and you did that by
Right, I just cut it in half.
cut it in half, because 50 is half of a dollar, so 24 is half. And you should always think 1/2 equals 50%. There's a fraction equivalent to a percent, equals 24. And now we're just taking halves of halves and adding halves. So let's see how that goes. So 25% is half of 50.
Right, which 25, half of 24 is 12.
All right, so there's our 12. And then 75 is 50 plus 25.
Right,
so
and
let's
I
put
like how
those.
you said that, because instead of just saying another way, I just think it's so quick and easy to say you just take those two and make 75%. That's easy. 36.
So there's our 36. And we already have this. So now we want to know 37 is going to fall where on this chart?
It's going to fall right in between here.
So it's in between the 25 and the 50%, which means your answer is going to be between 12 and 24.
Right, so it's going to be somewhere either 13 to 23, because it's not going to be 25 and it's not going to be 24,
Excellent.
so it's going to be one of those numbers.
There's a term we use for that, because sometimes we say between 28 and 12 and 48, and no, I'm sorry. Between 12 and 24, and they use the term inclusive or not inclusive, because you have to know, it's not 12 and it's not 24.
Nope.
So it's between 12 and 24, which means 13 to 23. So I'm glad you put that up there, because students include those, and that's not correct.
Right, because 25% would be exactly 12, and that's not what it is.
All right, so 37 is almost pretty in between these.
It is.
So we could actually then take another half of these numbers and go right in between here. But just by saying I know it's between 13 and 23 really gets you in the ballpark. And then you can use Cheyenne's skill, which was to do that multiplication.
Correct.
She told us, decimal is equivalent to a percent. 2 circles here means you move it over 2 places, 1, 2. That's just a little reminder. 2 circles in our percent sign, move it over 2 times. So we have 37 hundredths times the 48.
Right.
And you're so good with your math skills, I'll let you do the
Of
multiplication.
means multiplication.
Of means multiplication. Great.
All right, so let's multiply it out. 8 times 7 is 56. I'm regrouping. 8 times 3 is 24, 25, 26, 27, 28, 29.
And you know what? I sometimes do that with my fingers.
I just
it's
make
okay.
sure, just to make sure.
There's nothing wrong with that.
No, I don't need this guy anymore.
Done.
Because I'm done with my 8. Multiplying by the 4, that's not a 4, that's a 40. I need my placeholder.
Excellent.
4 times 7 is 28. Regroup the 2. 4 times 3 is 12. 13. 14. Sometimes I like to use my touch dots too.
Yep, touch dots.
I'm using all different strategies today.
Let's get this out of your way, but we're
Yes.
remembering it's between 12 and 24, or it's 13 to 23.
So if I'm adding 6, 17, 4, 5, 6, 7, love my touch dots.
Yep.
Now,
Now don't count those decimal points yet.
no,
Use those
don't
for
count
a
'em.
check.
That's right. If I were estimating, I would say it's 17.
Absolutely.
It's about 17.
Couldn't be 1076, couldn't be 177.
Nope.
Has to be exactly the 2 digits you circled. We're looking for a 2-digit number. And
right.
then this is just the extra part of the whole.
Right.
So 17. Now let's use our decimal point. So now we have 1, 2.
Yep.
Come to
1,
your
2,
answer. 1, 2.
There it goes.
Okay.
17 and 76 hundredths.
And we're using that as a check, but once you become efficient at this, you don't even need to do that. You know it's between 17 it's between 12 and 24, therefore 17 is the only place that that decimal point makes sense.
Right.
I like
Pretty
it.
easy.
I like it. That's, and once kids, percentages scare our students. Fractions
not
scare
scary.
our students, but this is not scary.
Not
this
at all.
is, look how easy this is. It's kind of fun. I love actually breaking apart numbers and putting them back together. I know I'm a little bit of a math nerd, but
I like the chart. I
yeah,
like the chart.
I like the charts, input output table. So we could actually take this table, and we did it one step at a time, but if we took this as a table, let's take these away. I could box this off, make it an input-output table, and take some of these numbers away and make you work for them.
Oh, you sure could.
All right, so let's say I take this one away and this one away. So using the logic we just used, we're seeing some patterns and we're seeing some connections. We're seeing patterns coming down, which is vertical. We're seeing patterns going across as well.
Absolutely.
So in and out or up and down, we're seeing the same patterns.
Yep.
So again, our quarters, 25, we can see if we go from 25 something, 75 to 100, we're jumping by 25s or looking at our quarters. So we know that the 50 is missing here. Percent. And here we're seeing,
Counting by 12s. 12, 24, 36.
oh, there you go, counting by 12. So each quarter represents 12 more. So
Yep.
this one becomes 36. Excellent.
Wow, that was pretty easy. That makes it a whole lot easier.
Yeah, it sure does.
And it helps kids understand why something is a certain way. We don't just want them to multiply and get some random answer.
No.
You need to know that 37% of 48 is a real number. It's 17.
And it means
something.
you're taking part of, you're taking a certain percent, and if you know 100% is the whole thing,
Right.
all the others have to be less than the whole number. So that's a nice way to look at
That's
it.
great. I love that strategy.
All right, so what else shall we share with them while we're waiting for our callers? We're waiting patiently, 301-772-0080. You're going to give us a call so we can help you with your math homework, or so you can, so you can do a challenge. You know that it's raining outside, so we know you're not outside playing.
right.
You should be working on your homework or some skills that you want to develop or improve upon from, again, you just took those fast tests
That's right.
last week, and some schools I know are taking them this week.
That's right. Well, we can talk about area and perimeter. How about those two?
Area and perimeter. Let's talk about that. What do we know about
those
area
are
and perimeter?
ones kids always have a problem.
That's what we know.
Distinguishing the two. All right. And the way I look at it is I like to remember the word perimeter. And I like to think of the word part rim.
Rim.
Like the rim, like the outside of a can. If you look at your little soup can, like the rim, the outside of it. And that's what perimeter is. Perimeter is the outside, the distance around the outside of a figure. So that's how I remember it.
Okay. And what I do to help me kind of remember the area, a lot of times we throw down an area rug. Now, I don't know if that's an old-fashioned word, if students would know that term, but we call an area rug something, if you have a floor, tile or hardwood floors, and we throw down a rug, any rugs really cover a space. So, Miss Shiry's telling me she's older than I thought she was because she just put this little fringe on my carpet. Area rugs used to all kind of have this little fringe hanging out. And so an area rug covers a space, and when we want to figure out the area, we want to kind of figure out the space inside that's covered. And typically, we're going to count squares. I'm hoping I'm coming close to looking like squares. And that's so good, but we don't have a tool. We're not using a tool, so we're estimating our space here. But the area rug is counting squares that cover. A rug covers a space. A perimeter goes around a space, around the rim. Think of the rim of your glasses, the rim of the can, as we just said.
Right.
The rim of your house or your backyard would be your fenced area.
Right. And all these area rugs always have some kind of border around them. They always have some kind of stitching or border that has to keep the rug together. So you could measure the distance around the perimeter of the rug.
Okay, excellent. A picture frame.
Picture frames are
Also,
good.
so the frame is the rim and the picture is the area. So that's another thing to help you remember. Again, we're throwing all these remembering things out there because students, for some reason, and this is up, you teach second?
Yep.
Second grade, third grade, fourth grade, fifth grade, sixth grade. I work up into sixth graders, and they confuse area and perimeter. So any little trick or strategy to help you remember which is which. And then, of course, what do you do with them once we have to do that? So you put some numbers here. The numbers represent, and again, I'm going to just put a U here for units. Because this unit could be inches, feet. It could be miles. It could be yards. It could be, we should use some metrics. They're all working on their STEM fair projects. Metrics would be meters, centimeters, millimeters, kilometers, depending on how big we're talking about. So unit stands for any of those, any of those. But if we're looking at perimeter, you go for perimeter, I'll do area.
All right, perimeter. I want to know about the perimeter, the rim, the outside. What I need to do is I need to add up the distance around each side. Now, even if they only tell you 2 sides, this one's a rectangle, so I know the opposite sides are equal. So if this side is 6 units, this side is 6 units. If this side is 5 units, this side is 5 units. Then all I have to do is walk myself around the whole figure and add those up. Well, I know 5 plus 5 is 10, 6 plus 6 is 12, 10 plus 12 would be 22 units, would be the perimeter.
And she did the opposites, put these two together, because when numbers are alike, they're friendly numbers. It's like doubling. So she put those together first. Excellent strategy. She has 2 numbers here instead of 4, but she could have had 6 plus 5, which is 11, plus 11 more, and doubled these 2 sides. She could have had 4 numbers written here. There's so many different strategies and ways to put numbers together. So whatever you're comfortable with is how you should do it. For area, again, Miss Shari went around the rim, the outside. I'm now going to go over the base of it, the covering space. My rug covers a spot. So what I would do, I can count my squares. Okay,
but they don't always have squares. They don't usually have squares, though.
Exactly, they don't have squares, which is why I put my squares in. But the concept is that we're counting squares. And if I'm sitting here counting 1, 2, 3, 4, 5, I know I have 6 across, and I know I have 5 rows. I'll be here a long time counting those out.
Yeah, you will.
So I don't want to do that. You keep hearing me use this word efficient. I like to be efficient in my mathematics.
Not very efficient to sit there and count squares.
So I could then say, well, I know I have 5 rows. If I have 6 in each row, so I have 6 here and 6 more would be 12, and 6 more would be 18, and 6 more would be 24, and 6 more would be 30.
30.
That's a shorter way of doing it, but the best, most efficient way is to know the formula. This is understanding the formula. We're counting all the squares, but the efficient way is to understand that the formula represents the length times the width, and I have 6 across by 5 up and down, so 6 times 5 units. I don't know why I said 5 and wrote 4. 6 times 5, all units, means that I have 30 units, but my units are in squares, so I have to put that little symbol here, which means 30 units squared, or I can write 30 square units. But if you don't do that, you're going to get it marked wrong, because it means you're not labeling it correctly. Okay, so we have 2 ways of doing it: 30 units or 30 units squared or 30 square units. Both of these say the same thing. And again, we don't want to have to count the squares. 3rd graders might. And do you do area in 2nd grade? Do you start it?
We do area.
By counting
and
squares.
Perimeter.
Okay,
Correct.
so you start by counting the squares, but as you develop your math skills, you move on to multiplying to be more efficient.
That's more efficient.
Yeah.
All right. Well, you know what? It's already time for a break.
Oh, wow. Time flies when you're talking a lot.
I know. We have to get our little commercials in. So stay right where you are. I know you're just sitting there by the phone waiting to call us. If not, we're going to come back and teach you a whole lot more math. So stay tuned. We'll be right back.
Hello, my name is Jeffrey Greer, and I am here with your email corner of the day. Today we are going to work on adding mixed numbers with unlike denominators. Here's our problem. 5 2/3 plus 3 3/9. What we need to do is find a common multiple of both 3 and 9. The common multiples of 3 is 3, 6, 9. the common multiples of 9 is 9. Stop right there. 9 is a common multiple of both 3 and 9. So we can leave 3 ninths alone and work with 2/3. Since 3 times 3 equals 9, we need to multiply by 3. 3 times 2, and we get 6. So now we have 6 ninths. 6 ninths plus 3 ninths equals 9 ninths. Now we need to add the whole numbers. 5 plus 3 equals 8. What we have now is 8 9 ninths. 9 ninths can be reduced. This equals 1. 8 plus 1 equals 9. 9 is your answer. Thank you for joining me of your email corner of the day. Thank you.
You can never know which pull safety step will save a life. Until it does. No matter how safe you feel, adding multiple safety steps can mean the difference between a close call and a call to 911. Simple steps save lives. To learn some new ones, visit poolsafely.gov.
When lending a helping hand to those struck by disaster, we often send help in the form of goods. But did you know how much money goes to the shipping and storage costs for just one of these? It could have been used to provide necessities such as clothing and shelter for so many more people in need of our help and love. The love helps. Send helpful love. Cash is best. For more information, visit www.cidi.org.
Welcome back to the elementary version of Count on Us. We're halfway through, so if you want to get your math homework help, you got to call us now. 301, the number's flashing. 301-772-0080. We were excited because we were watching the PSA, or the little mini lesson actually, and we saw one of Miss Shiry's students from Perrywood. So we are willing to take students to do mini lessons.
That's right.
If you are interested, you need to contact Count on Us. You can send a message to the email corner and say you would like to be one of the students to solve one of our email corner problems. And that would be COU, Count on Us, at
pgcps.org.
All right, so on that note, we just got word that our students did not do a great job with pictographs.
Pictographs, that seems so easy.
It seems so easy, but you know what makes them difficult?
What?
The key.
Oh, the key, that's right.
The key, they forget about the key. So let's take a look at a pictograph.
Okay.
All right. And knowing that the STEM and science fairs are all coming up, and students are working on that scientific method.
Yes.
One part of the scientific method is that data collection and results. You got to collect your data, usually in a table, maybe a tally chart. I'm not sure what kind of collection you'd be using, but then you have to report your results out in a kind of a graph.
Sure.
Now, pictograph, I'm not sure would be the best kind of a graph in the science fair.
Probably not, but it still could be pretty important.
Yeah. So let's look at a pictograph, but also know that, especially our intermediate students, 4th, 5th, 6th graders, you're looking more at line graphs, bar graphs for yours. But our primary students may use pictographs for things. And you guys are doing pictographs in second grade.
We don't do them yet, but we will do them.
And do they typically go across or up and down?
Across.
Across. So let's do a pictograph.
Okay.
Let's look at
We could do weather, the number of sunny days.
Sunny days, rainy days. We got a rainy day going on, and we had weather that was in the 70s last weekend.
Know.
I was in shock. I was outside playing tennis in this
Absolutely,
gorgeous
it was
weather,
beautiful.
and then it got cold.
It's going to get cold this weekend, too.
All right, so pictograph. You want to do a sunny?
Okay.
I'm just winging this here.
You
We
go.
got a sunny day. We have a. Let's see if I can make this look like a raindrop. Nah, that doesn't look like a raindrop.
No. A little bit more curve.
A little more of a curve, but it should be the circle up here and curvier down here.
There you go. That's good.
Raindrops. All right, I'll do 2 raindrops.
Wonderful.
So we have
Raindrops.
rainy day, a sunny day, or a how about a cloud?
Cloudy. It's
Cloudy
kind
days.
of cloudy.
So if the sun's not out, it could be cloudy without raining.
Sure.
So it's rain. Okay. So here we go. Now these are the pictures we're actually going to use in our pictograph.
I don't know. We could use something else. Let's
Okay.
see.
Let me
What-
connect it with the same color. All right.
We're talking about weather. So let's see, what kind of symbol could we use for weather? That would be for a pictograph.
Or we could, well, yeah, how would we do that?
We could use people.
People.
Because how many people would go outside during a sunny, rainy, we could collect some data
or what
like
kind of day do you like best?
Oh, yeah, that's
Let's
true.
do that.
How many people? Okay.
So people, how many people like sunny days, rainy days, or cloudy days? Now, I'm not sure who would like the cloudy days, but there are people that like rainy days.
I like cloudy days. Cloudy days are good if you're taking pictures because you don't want that direct sun. So you could like some cloudy days.
So here, let's do this here. And let me put, so we're going to say people. So I'm not a great artist, and I always tell the kids we're not looking for
it doesn't
artists.
matter. You just need to make a stick figure.
That's exactly what I'm going to do. So I'm
There
going
you
to
go.
put this here. I'm going to put this here, and I'm going to put this here. And over here, I'm going to put this. And over here, I'm going to do this. 1 and 2 here. But you know what? I'm going to add that key that I told you they have problems with.
Oh, yes. Here's the key at the bottom.
Yeah. I'm going to put a key here that says this equals 5.
5.
5.
Ooh, 5. Okay.
Is that too many?
No.
That equals 5.
We do that in second grade.
Okay, excellent. So you have to always, Pictograph, they try to trick you because they put this key here, and if you forget to look at this key, you're in trouble because you're going to say 1, 2, 3, and that is not correct.
That's not correct.
So take it away. What would you tell your kids?
That's right. You have to look at the key and you see what the symbol is. Each person represents 5 real people. Because what happens is sometimes they make the picture represent a higher number because we can't fit all those people on there.
we'd have to have a lot to have. Yeah, we wouldn't have enough room
Remember
for
how
that.
you talked about being efficient?
Yep.
That's not very efficient.
Yep.
So what we're going to do is we know our multiples and we can count by 5s and we'll have plenty of room, and it's much more efficient to draw 3 people than it is to draw 15 people.
And I love that you use the word multiples. Is it
yeah.
you second graders learning the word multiples?
I teach my second graders multiples. We count by multiples of 5. So 5, 10, 15. So 15 people enjoy sunny days.
All right, let's write that down. So we have 15 there.
And then rainy days, 5 people still like it when it's rainy. I like it when it's rainy too. Then you can sit inside and read a good book.
Cup of hot cocoa.
And then cloudy days, there are actually 10 people that like the cloudy days.
So then I can say to you, and we wrote these numbers here, and I always tell students you can write on your charts.
I always write on the tables and charts.
Absolutely, because then I can say to you, well, the easiest one, of course, is which type of weather do people like the most, and that's easy by we don't even have to use these numbers,
right?
To answer that, we can see this has the most. But what if I said, how many more people like sunny days than cloudy days?
So let's see. Sunny has 15, but we don't even have to look at these numbers yet. Sunny has 3 figures. Cloudy has 2 figures. Well, Sunny has 1 more extra figure than that, so my figure equals 5. 5 extra people.
5 extra people. I like that. But you know what they're going to do to you? When they have, we have another blank one? Because I don't want to erase this table here. But I want to tell you that they're going to give you choices here, and they might say A, B, C, and D. And you know what they're going to say? They're going to say 1.
1.
They're going to put 1 as the answer because you know how you said there's 3 here and 2 here?
There's 1 extra person, right.
And that's going to be one of the choices because they try to trick you. They want to see that you can really prove and justify that you know what you're doing. So, yes, they might have 15 as one of the answers. They'll probably have the difference between them, which is 5, and then they'll probably put 10 here.
Yep.
So these are confusing answer choices.
They sure are.
You
need
have
to make
be,
sure you know.
Exactly. You have to be really sure that you're not only doing that comparison, because when they say how many more, how many less, you're comparing. You have to do that comparison, but then you have to make sure you look at that key, pictographs and keys. I'm gonna see if I can trick you, Miss Shirey.
Okay.
Because you know what I want to do? Watch this. I'm gonna put this up here. I'm gonna see if I can do this.
Oh, half a person, 1.5 people like rain? Oh no, that's kind of hard because we have an odd number for our key.
We do have an odd number. Let's change it.
Let's change the key.
We can be flexible. So we're going to change these numbers here.
We're going to change the key.
And I'm going to change my key. And I'm going to change it. Let's see if Miss Shirey catches me. I'm going to change it to 3.
3's still an odd number.
I'm just
That's
making sure
pretty
she's paying
hard.
attention. I have no students to see if they're paying attention, so I have to see if Miss Shire's paying attention.
Now, you could do half of 3, but
Yeah, we don't want
not, really
not for
a graph,
primary, because
no.
especially primary students are typically the ones that are doing the pictographs.
Right.
So let's. She wants me to use an even number.
Right.
As soon as she says even, I know I'm looking at my 0, 2, 4, 6, 8. Okay. So that has to be in my ones place. You know what? I'm going to give you a big number.
Big number.
I'm going to give you a big number. I'm going to move this key over because I'm going to give you a 2-digit number.
Oh, no, a 2-digit number.
So each one of these equals 10.
What?
That's an even number. You said I can
That's
any
right,
even
that's
number.
Right. Okay, well, let's see. Now my key has changed to 10, but the other information on the key really hasn't changed. I mean, on the graph hasn't changed.
Right.
So I'm just counting by tens, by multiples of 10.
All
10,
right.
20, 30. So 30 people enjoy sunny days.
All right, I like it.
I'm going to leave this one for last because that's tricky. I'm going to go cloudy days. 10, 20. 20 people like cloudy days. Now, this part really isn't as hard. I'm not fooled. The whole person was 10 people. Plus, if it's half a person, that means it's half of whatever the number in the key
All
is.
right.
Half of 10
Making
is
it
5.
sound easy.
So there were 15 people that liked rainy weather.
15. So I really didn't trick
got
you,
it.
and we wouldn't trick our students either, because if you go through these steps and make sure that you're just following directions and logic, that's really all it is. So now I can also say, the first time I said how many more, so now I'm going to ask her a how many less question. How many less people like rainy days than sunny days?
Wow, rainy days than sunny days. Well, there are 20 people for cloudy and 15. This time I'm going to use the numbers instead of the pictures.
Okay.
20 minus 15 would be 5. There's 5.
Okay, now what was my question?
5 less people like rainy days than cloudy days.
Oh, I thought I said sunny days.
Sunny days.
I thought I said sunny days.
Sunny days than what? Which two were you comparing?
How many less or fewer people like rainy days than sunny days?
Oh, all right. Well, 30 people like sunny, 15 like rainy. I'm still going to use my numbers. 30 minus 15. Oh, I know that's 15.
All right.
15 less people.
You got it. Now I'm going to ask you, I think, a little higher order thinking here.
Okay, all right.
I want to know, do more people like rainy and cloudy together than sunny?
Ooh, that's kind of hard.
2 parts.
All right, well, do more people like rainy and cloudy than just sunny? Well, first of all, I have to put rainy and cloudy together.
Okay, 2-part problem. That's
So
what I
I
said.
know 20 plus 15, that's easy, 35. I know my mental math. So 35 like those two together. 30 like sunny because you're comparing these two against just that one.
So what would that look like on a number sentence?
All right, so a number sentence would be 35 people is more than 30 people that just like the sun.
Okay.
Oh, I have a question for you.
Uh-oh.
I'm going to try to trick you this time. This is a question that I know a lot of students get wrong on pictographs or bar graphs or any kind of data where they're surveying people, and they will say, how many people were surveyed for the weather?
1, 2, 3, 4, 5, 6, 6.5.
6.5 people. Well, first of all, you know that's not right because you don't usually have a half of something.
And as soon as something doesn't sound right, you know if it's not making sense, then you have to go back and relook at it.
Right.
So how many people surveyed? And that is a good question, especially line plots are one of the biggest
They
places.
always ask them that, and everybody
Always.
always messes it up, and it's not hard.
So how many people were surveyed? I can do it 2 ways. I can count my figures here and multiply by 10 or count by tens. I'm comfortable with my tens, my 10 multiples or multiples of 10, so I'm going to do that. If each person is 10, I'm going to say 10, 20, 30, 40. I'll save this one like you did.
Okay.
50, 60. So I did all of my wholes. So I have 60 surveyed so far. And then I have half of 10, which is 5. So I'm going to go with 65.
Very good. All they're
right.
asking is how many people in all. When they ask you how many people did they survey or how many people are on the graph or chart or table, they just mean add them all up. Find the total.
And if we added them up, and the first way I did it when I said there was 6.5 or 6.5, well, let's use the half because it's a half a person. 6.5, and then we know each one equals 10. So actually, let's set that up like a ratio. Let's see what that looks like. So 1 is to 10 as 6.5 is to x. How's that?
Whoa, that's kind of tricky. Ooh, we can cross multiply though.
Yes,
We
you can
do that.
You can cross multiply. Or what did we do to get from the 1 to the 10?
Multiply by 10.
Whatever we do to our numerator, our number on the top, we do it to our down number, which is our denominator. We multiply times 10. And when we're multiplying decimals times 10, all we really do is shift our decimal point.
That's right. We're very efficient. We know how to do that.
Equals 65.
Hey, we figured it out.
So look how many different ways that we're looking at in terms of how to solve problems. You have lots of options. A lot of students think, oh, that's math. I have to solve it. I have to get one answer. And, well, yeah, there might be one final answer, but what's fun about it is the way you get to that answer is all on you. Your teachers may teach you a strategy, but if you learn a strategy that's more efficient, that works.
That works.
And works every time. Okay,
And
it
you
can't
can
just
use
work
it.
this one time. It's got to work every time, and you can use it efficiently. Then your teacher should have no problem with you using that strategy.
You know what else we were studying?
What else?
Solid figures.
A solid as opposed to a liquid figure?
No,
Oh,
solid.
I
meaning
work
like
at the Science Center now, so we do liquid, solids, and
three-dimensional.
gases.
Three-dimensional.
Oh, three-dimensional. All right.
Meaning
I
it
like
has
drawing
length and
those.
width and height. Do you know how to draw them?
I like to try because it's a mathematical spatial relations kind of thing.
I teach my kids how to draw three-dimensional figures. The second graders have loved it. We have taught them how to draw cubes and rectangular
cool,
prisms.
cool.
And they think it's great. But within doing that, they think they're just having fun. But they're really not. They're really learning how many edges, vertices, and faces are on certain solid figures. Now, all you have to do to draw a solid figure, a three-dimensional figure, if you want to draw a cube, just draw 2 squares. Draw 1 square, and then put your pencil in the middle of that square and draw another square.
And then I like the what part that comes next because now you're using your geometry skills because you're going to draw parallel lines.
You are. So you're just going to connect the corners from here to here on this square and from here to here on that square.
And when I say parallel, this is a straight line at this angle, and this is the same straight line at this angle. These angles are parallel to each other.
Right, they're
These
not
two
gonna
lines,
touch.
they're not going to touch. And if we continued them down, they'd be the same way. And in the same way, she's drawing that one. Perfect.
There you go. Look at that. All of
your
a sudden,
cube.
you can visually see a cube. Now, on paper, we can see how many edges, vertices, and faces there are in a three-dimensional figure.
Okay, so edges and vertices, and what was the third thing?
And faces.
Edges.
Like your bright smiling face. Faces.
Look at me. I'm like adding extra
You're
lines.
trying to mow the lawn. You're putting your edger.
Edge is
Edges.
faces. And what was the third thing you said?
And vertices.
Vertices. Now, edges has another name. The sides?
Sides. Well, no, the faces are the sides. The faces are really the sides. The edges are where the sides come together.
Okay, the line. Yeah, the lines maybe. Then? All right. The book uses edges, faces, and vertices. All right. So
Now,
notice how I
if
like
you
to
draw
make-
them out like this, if you can learn how to draw three-dimensional figures, finding these pieces
Simple.
of it's so easy.
Simple.
So easy. Now, edges is probably the most difficult one. Let's see. Well, first of all, there are 4 edges at the top. 1, 2, 3, 4. I always start at the top. I like to be very efficient, like you said. There are 4 edges at the bottom. 1, 2, 3, 4. And all you have to do is trace over them. And then there are 4 connecting the top to the bottom, 1 for each corner. So 4 plus 4 plus the 4 that come down, 4 plus 4 plus 4 is 12 edges on a cube.
Excellent. So that was the strategy Miss Shirey likes to use. I like to count my faces by saying I know I have a front and a back.
Yep.
I always have a front, so here's my front, and this one here is the back, and it becomes kind of illusional or
Right.
disillusional when you're looking at them, but there's a front and a back. I know there's a top and a bottom,
Yep.
and I know that there's a right and a left, or 2 sides.
There has to be 2 sides.
So we'll say right and left. So between the front and the back, top and bottom, right and left, I'm going to say that there are 6.
6 faces.
And I can connect this to my real life in that I know that a die or dice or number generators have that many sides.
Right. Now, the vertices are quite easy. All they are where the 3 faces come together, and I like to circle my vertices. 1, 2, 3, 4. I have 4 at the top, and then 1, 2, 3, 4 at the bottom for a total of 8.
We're gonna 6 here,
12 edges.
12 here,
and 8 vertices.
and 8. So is there a relationship?
I guess, I don't know.
Interesting.
I mean, there are twice as many edges as faces.
There are twice as many edges as faces because each face has how many edges?
Well,
Each face has 4.
right. But
So-
they touch each other and you don't,
Exactly.
you don't count them twice.
So you don't count them twice. So let me move this over now because now what we're going to do, this is a square. You know what I
Well,
want to know?
cube. It's really a
Oh,
cube.
cube. I'm sorry, you're right. It is not. It's not a square. It has a square face, but it is a cube. We're looking at 3-dimensional or solid figures.
Right.
I want to know if I take this. One of the faces is a square, which is why I had the square in my mind. I was looking at that because I want to now take this square and I want to expand it out,
Stretch it out.
stretch it out, make it into my rectangle.
Ooh, rectangular prism.
You got it. And I want to see the relationship here. Rectangular prism.
So all I'm doing is stretching it out.
So you're going to do the exact same thing. You're
I'm
drawing
gonna do
another
the
one.
Right, except instead of drawing a square at the beginning, you draw a rectangle. And then all you have to do is connect
The parallel lines.
the corners, just like that.
Perfect. So then we should be. So then do they match?
They match. They're exactly the same.
So if we use the same strategies, this time I'm going to use your strategy and you can
Okay.
use mine.
All right.
So you said in terms of edges, you said my top has 1, 2, 3, and 4. You said my bottom has 1, 2, 3, and 4.
Right.
And you said connecting this side I have 1, 2, and connecting this side I have 1, 2. So that's
Correct.
4 more.
12 edges.
12 edges.
So they're in the same family. They're very similar. Okay, they
Okay.
have 6 faces. So I see 1 on the top and 1 on the bottom,
Top and bottom,
1 in the front, 1 in the back,
front and back.
and 1 on the left and 1 on the right.
Left and right, those same things I use. So we have
6
6
faces.
here. And then those vertices, I guess, would be 1, 2, 3, and 4. 5, 6, 7, and 8.
Yep, very good.
All right, so a cube and a rectangular prism have the same. What about, I'm going to trick you on this one.
A sphere. Ooh, a sphere has no edges.
No edges because there's no straight lines going on, huh?
And no flat faces.
No flat faces because it's round.
Right, and no vertices.
No points.
Nope.
They're not meeting. The edges aren't meeting anywhere.
No, not at
so
all.
so this is a big fat 0.
0, 0, 0. Yep.
Excellent. 0. Okay, what about prism? When we talk about prism, what does prism mean?
Prism, well, that's a good question because a lot of students get very confused by prisms
And
and pyramids, but they're really not hard. I don't understand why anybody gets confused. Prisms are always box-like objects, okay? Pyramids always have come together at a point.
Okay, so I'm going to draw one. I'm going to try drawing a 3-dimensional figure. So if I draw, let's see, keeping my lines parallel, I'm going to draw this. And then I'm going to connect 1, 2, how's that?
And then you can draw one that comes.
You can see the back one.
the
Okay.
back.
Anytime you see dotted lines in a solid figure, it's a line behind that we're not seeing, that you should see. If you rotated it, you'd see it. Okay.
Now, a pyramid's very easy. Edges, all you have to do is trace again. 1, 2, 3, 4. There's 4 edges for the base. 1, 2, 3, 4 more edges coming down to do the triangle part of
Okay.
your pyramid. So that is 8 edges.
And I actually wish I had a way of opening this up. If we made it into a net, this would look like a square on the bottom, and then each of these would open up into triangles, and then we kind of close these triangles up to make the pyramid. These kind of fold in
Yep.
and meet at this point.
Right.
So how is a prism different?
A prism is like a box. It does not have this top. It doesn't have this top part up here. It doesn't come together at a point.
So what would it? Can we draw it? Is what my question is. How would we draw that?
Well, you could draw, well, any kind of prism. A cube is a prism. It's just a special kind of prism. It's a prism where all the faces are the same
Okay.
shape.
But what about a triangular prism?
triangular prisms.
Is that how, can we draw that? That was my, I guess that's why I'm...
Yeah, I guess we could.
Yeah.
I guess we would just start with a triangle. I don't know. I'm not very... Oh, I can kind of do these.
There you go.
There we go. And
Some of those would probably be dotted because they would be dotted.
Yeah, they're kind of... This is the prism that you think about, like that makes rainbows. Yeah, I guess I'm dating myself now, how old I am. But when I was little, we used to get a piece of glass that was shaped like this in a triangular prism and put it up in the sunlight, and then you would see rainbows.
And for students, the difference between the triangular prism and the rectangular prism, the ends.
Right,
one
the
of them has a
faces.
rectangle on the end, and one of them has the triangle on the end. If they're still connected, I guess I should have gone a little angly here. So let me come back here for a moment. Here, let me slant that a little bit. All right, now if we connect, and I'm close. I'm off
you're
by
pretty
one.
close. Yeah.
Okay, but our rectangular prism and triangular prism, the only difference is the
It's the base.
The base.
The base is on either end, if you stood them up, I guess. You can also have a hexagonal prism. You can have a
Exactly.
pentagonal prism.
and that's how you name it. So it actually has the number of sides based on the base. Based on the base.
Based on the base. Where pyramids, you can have a triangular pyramid too, where you would have a triangle base instead of that square or rectangle.
And the pyramids all come to points? Okay, so our pyramids come to our points. Our prisms have different bases that give us a number of sides.
Yeah, and I just think of it always as a box. These always kind of look like boxy over here, where these you can tell because if you're not going to be able to sit them up on every side. A prism, you can you can stand them up on every side.
Okay, that's a good way
That's
to
how I figure out
discriminate
the
between
difference.
them. All right, you know what?
It's
wrap up time. We've done a lot of talking and teaching and learning today. We hope you got something out of the show. We didn't have many callers, but we did have one. We have two names in here though, so we'll have to see who's the winner here. Even though
It's the
I
same.
think the probability is that Cheyenne is in here twice. So Cheyenne, I hope you're still watching because we're both going to pick, and one of us is going to pick the winner. Let's see.
Let's
you pick
see.
one, and I pick one.
Okay, even if we pick two.
But my person's going to be the winner. My person is
Cheyenne.
So congratulations to Cheyenne. We thank you for calling us. We hope that we have some students getting ready to call for the next show because we're on for another hour from 5 to 6 where you can get help with your middle school homework, your algebra, your pre-algebra. Sixth graders you can call. And Shirey, it was enjoyable talking with you and working with you today.
Absolutely.
Too bad we didn't have more callers, but remember that for Miss Shirey and myself, you can always
Count on us.
Hi, welcome to the Count on Us mini lesson of the day. I'm Miss Shirey. I'm going to talk to you today about place value. Let's look at our problem. Place value, a mini lesson on the value of numbers. Our objective for today is students will use place value blocks and a place value chart in order to understand the value of numbers. Here we have a problem. It says Ian and Olivia were trying to decide who had more baseball cards. Ian has 4,237 cards. Olivia has 4,327 cards. Their friend Sammy said that they each had the same since all the digits were the same. Was Sammy right? Let's take a look at a place value chart to help solve the problem. Sometimes a chart like this can help. Ones, tens, hundreds, thousands. If you put the digits in each of the place value places, we can tell who has the larger number. Here's Ian's number, 4,237. Here's Olivia's number, 4,327. Look in the highest place, then keep going. You can see they both have a 4 in the thousands place, but look, Ian only has 2 hundreds, Olivia has 3. Let's look at it with a place value blocks. Here's a picture that shows you 4 thousands, 4 thousands. They're the same, but you can see Ian only has 2 hundreds, where Olivia has 3 hundreds. You can see by the place value blocks that Olivia has more blocks than Ian. Each place really does have a certain value. Sammy wasn't right on this problem. Well, thanks for watching. We'll see you next time on our Count on Us mini lesson of the day.
Hello? Hello? I've been on the street for a while. I saw your poster outside. I don't know what to do.
National Runaway Switchboard, how can I help? Call 1-800-RUNAWAY to make the connection.
You have the time to give. You have the capacity to care. You have the experience to contribute. And your country needs you, one of its greatest assets. Americans whose lifetime of knowledge and know-how will make the difference. Take what you learned in the workplace and apply those skills to your community. Shape tomorrow by being a mentor and tutor for children. Make independence a reality for people who need assistance and companionship to continue to make their house their home. Make a difference today. Get involved.
What's happening? It's your Royal Hypeness, Angie Angel, your Mike 93.9 WKYS is my radio station, 6 to 10 p.m. Check me out. And when I'm having problems with my math, I'd call in to Count on Us. I can always count on them.
Because how many ways are there to solve math?
Many!
Your life homework help starts now. Welcome to Count on Us.
What is the length from the entrance to the giant wheel?
All right, so let's add 3 here and see what happens.
First, measure first. I need you to double check yourself. So the second equation for solving perimeter is?
2 times length plus 2 times width.
And welcome to your Telly Award-winning Math Homework Hotline. I am Mrs. Davis here with...
And I'm Mr. Belton. Welcome back. Happy New Year.
Hopefully things are off to a fantastic start. I know many of you have finished up your fast testing, but remember, fast testing is your preparation for the NSA. So with math, you want to keep going back and reviewing skills, and as you learn new things, you want to review those as well to make sure you are proficient and advanced. With our homework hotline, we have 24 challenges that you can challenge yourself with after you've had an opportunity to ask a math homework question. So, Mr. Belton, help me out.
We have 4 cards here. The 1 dot, which is the easiest of the 4. We have 2 1s, an 8, and a 4. Okay. Card B, we have 2 6s, an 8, and a 2. Card C, we have 2 6s, a 2, and a 5. And card D, which is the most challenging of the 4 cards, we have a 7, a 5, a 3, and a 2. Remember, boys and girls, you want to combine any 4 operations and use each number only 1 time to produce a result of 24.
Okay. Okay, so once you've had a chance to ask the math homework question, you can challenge yourself with the Challenge 24. Remember, you want a total of 24. That's why they call it Challenge 24.
How was your day, Miss Davis?
My day was wonderful. We've been working very diligently, trying to review some things to get ready. Always keep ourselves fresh for MSA preparation. And
so you all have had the fast test this week as well?
Yes, we did. We had the fast test, and I'm sure our students did fantastic.
I sure hope mine did fantastic as well. Anything in particular you all have been reviewing?
We've been working with percents.
Percents?
Finding the percent of a quantity.
Okay.
And I am sure we're going to have callers calling in today. So call now. The number is 301-772-0080. So call in right now with any math homework question that you have. That is Comcast 96.
And Verizon Channel 38.
Verizon Fios Channel 38. And if you have DirecTV, you can watch us on the web at www.pgcps.org and click on your live web broadcasts.
All right.
Okay. So
you want to show us one of your percent of a number problems?
Well, we can try a percent of a number.
We actually
started out using a model to help us to find the percent. Let's say that we were using some fine or we used a model method. What is 20% of 60? What is 20% of 60? And some students may have seen this method before. It works really well when you have a percent that is a multiple of 10.
Okay.
So we used a model that was in the shape of a rectangle. Okay. So, and it was divided into equal pieces. Now, I might have some difficulty with these equal pieces. So, this would 1, 3, and let's just 4. Okay, those are not quite equal. Okay, so my goal right there was to make 10 equal pieces. So if I put my percent up here at the top, that would be 0%, and this would be 0. Okay. Over here on this end would be 100%. And so 100% of the number I'm trying to find, which is 60. Okay, so, and since I've divided this into 10 pieces, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, each one of these would represent 10%. 10%. So this would be 10%, 20%, 30%, 40%, 50%, 60%, 70%, 80%, 90%, and I'm there at my 100%. Now, to help us with our math reasonableness, I can think half of 60 would be 50%, or 60 divided by 2 would give me 30. So I know that my 30 would go right here in the middle. Now, to find out the value of each of...
Is that where you always have your students start, with 50%? Right in the center?
Nope, I actually do not. But just to help with our number sense and our reasonableness, I actually start with figuring out what is the value of each of these pieces.
Okay.
And we would actually do that. Since I have this divided into 10 parts, I'm going to divide 60 by 10. And 60 divided by 10 is 6. So then, since I'm dividing by 10, I now know that 10% of 60 is 6, 20% of 60 is 12, 30% of 60 is 18, 40% of 60 would be
24,
and 50% of 60 would be 30. And so this would be my check to see if indeed I'm going to come right here to 50% being half. Okay? So I can continue. It's as if I'm counting by sixes. So that with my students, that's helping refresh their multiplication, which is something that all students need to keep fresh in their minds. So,
definitely.
So 60% of 60 would be 36. 70% of 60 would be 42. 80% of 60 would be 48. 90% of 60 would be 54. And 100% of 60 would be 60. So the whole thing. So the reason that I did my 50% because that's helping me with my estimate. I can tell if I want 20% of 60, that's going to be some number less than 30.
Okay.
Okay. So now I want to find 20%. The great thing about this model is the percent. The answer is right here. All I need to do is circle it.
Okay.
So I know that 20% of 60 is 12. So this equals 12. And we also learned to check our work using the multiplication method. So we call this the model method. And we also have something called the multiplication method.
Now that's the method, if I understand you correct, that's the method that my students typically use, where we look at the word of. And we know that
translate
of
that
signals multiplication.
Okay, so would you like to expand on that with the multiplication method?
Because there's always more than one way to do a math problem. So first things first, we would convert 20% into a decimal, which would be...
Would you like for me to write?
Please.
Okay.
Which would be...
Okay, so I have 20% of 60. And I'm not sure. We might have a caller. Is there a call there?
Yes.
Oh, okay. Hi, caller. Hi, caller. Welcome to Count on Us. Can you tell us your name, please?
Kyrie Caesar.
Hi, Kyrie Caesar. And can you tell us what school you attend?
I go to Stephen Decatur Middle School.
Stephen Decatur Middle School. And who is your teacher at Stephen Decatur?
Good.
Who is your teacher?
Good.
Okay, your teacher is good.
Your teacher
well,
is
welcome
good.
to Count on Us. Is this your first time calling?
Yes.
Oh, Mr. Belton, our first time caller, Kyrie.
How can we help you this evening, Kyrie?
I was wondering, how do you divide decimals?
How do you divide decimals?
Okay. Well, Mr. Belton and I will be happy to assist you with that, dividing decimals.
Do you have a particular problem, Kyrie, that you're working on?
Yes. I was wondering how you divide 0.80 divided by 0.20.
0.20.
Okay, now the first thing, instead of saying 0.80, we can read that as 8/10 or 80 hundredths.
Okay.
And instead of saying 0.2, we can read that as 2/10 or 20 hundredths.
Okay.
All right?
Yes.
Okay, did we write the problem correctly?
Yes.
Okay. So 80 hundredths divided by 20 hundredths, is that correct?
800. Yes.
Okay. Okay, Mr. Belton, I'm just going to be the writer for you.
All right, now.
How do we figure out what goes
Which
where?
value goes under the division bar, Kyrie?
Wait. Can you say that again?
Which one of the decimals goes under the division bar?
0.20.
Not 0.20. not 20 hundredths.
Sorry. I mean 0.80. Sorry.
Okay, 80 hundredths.
80 hundred.
So that goes under the division bar. What goes outside of the division bar?
0.20 hundredths.
That is correct. Now, in dividing decimals, Kyrie, we have our decimals in the same place, correct?
Yes.
So what we can do is we can move both decimals how many times?
2 times.
In what direction?
Right.
To the right. So 2/10 or 20 hundredths, we've just converted that into what?
A percentage.
We've converted that into 20 because we moved our decimal twice to the right. And 8/10 or 80 hundredths, we've converted that into
80.
80. Now, because we moved each decimal twice to the right, when we divide, we're not going to change our answer. So now, Kyrie, how many times does 20 go into 80?
40. No, 4 times. 4 times.
4 times?
4, yes.
Okay, where does that 4 go?
On top of the 0.
On top of the 0. Now what do?
We times 20 to 4.
Okay, 20 times 4 is?
80.
80. And our remainder is?
0.
0. So 20 divides into 80 exactly 4 times. Therefore, 2/10 divides into 8/10 exactly 4 times. Does that help you out?
Yes.
Okay. So we will have another 4 above the 0 there. You have any further questions, Kyrie?
Nope, that's it.
Before you go, would you like to try a 24 challenge?
I guess.
Okay. Okay, which card would you like to try?
The bottom right.
Bottom right, the 3 dot. Oh, you want the challenging card. Okay. The 3 dot is the most difficult of the 4. So we have a 7, a 5, a 3, and a 2. Kyrie, are you familiar with the 24 challenge, how it works?
No.
Okay, your task is to use each of the 4 numbers only 1 time. But you have to use all 4 numbers. You can't use 3 of them. You can't use 2 of them. You have to use all 4 numbers 1 time. Any combination of the 4 operations, and you want to produce a result of 24.
Okay.
You ready?
Yes.
Okay. What do you want to do?
3.
3.
5.
What do you want to do with the 3 and the 5?
I want to times it.
Okay. 3 times 5 is equal to what?
15.
15. Okay, so you've canceled the 3 and you've canceled the 5. You can no longer use those. You still have the 7 and the 2. So far, you're up to 15. Remember, you want to get 24.
Okay. I want to use the 7.
Okay, what do you want to do with the 7?
Add it with the 2.
Add it with the 2, okay. You add 7 and 2 and you get?
You get 9.
9, okay. Now, you right there, Kyrie. What do you want to do next?
I want to do it 15 plus 9.
15 plus 9. What's 15 plus 9, Kyrie?
24.
24.
Kyrie, a first time caller, you met the challenge. Wow.
Good job, Kyrie. So your name goes in the hat not once for calling.
Once for calling and once for meeting the challenge. And you are our first caller of the show.
Very good, Kyrie.
Did you challenge any of your classmates to call in to Count on Us as well?
I'll do it right now.
Okay, and who should we, which of your friends are you going to have call?
Joshua.
Okay, well, we will be waiting right here to hear from Joshua and all the students who happen to have math homework today that need a little bit of help. Kyrie, thank you so much for your call, and stay tuned at the end of the show to see if you are indeed a winner. Your name has gone in twice, so you've doubled the possibility of being a winner.
Good job, Kyrie.
Can you imagine a first-time caller getting both?
And he chose the most difficult card.
Let's put those
That's what
back.
I'm talking about.
Let's put those cards back up to make sure all of our viewers there at home get a chance to check them out.
Again, this is the 24 challenge. You want to produce a result of 24, choosing any one of the 4 cards of your choice. And you have to use each number one time and one time only. And any combination of the 4 operations to produce a result of 24.
Okay, and just go ahead and jot those down before you call in to give yourself a chance to work them out. Card A, the choices are 8, 4, 1, 1. So since you have 2 ones, that means you need to use 1 twice. Card B, 2. Since this is not shaded in, it is a 6. So this is 2, 6, 8, 2. That is a 2 dot. It's considered one of our more difficult ones. Our medium. And this is 6, 6, 5, 2. And card D that Kyrie just helped us solve is 7, 2, 5, 3. And you know, Mr. Belton, the great thing about 24 Challenge, there's usually more than one way to solve these particular challenges. So even though Kyrie did one way, with card D, there might be, and most likely is, another solution.
Always more than one way to do a math problem.
That is the great thing about math. Okay, so go ahead and jot those down, and when you call in, you get a chance to challenge yourself as well. And Mr. Belton, I believe you were showing us the multiplication method for finding percent.
All right, now we can get back to that. What I have my students do first is convert the percent into a decimal.
And exactly how do you do that?
Moving the decimal twice to the left. So 20% as a decimal would be 2/10 or 20/100.
Okay. Does it matter which one you use?
No, it doesn't matter.
Okay, so which one shall we use?
We can go with 2/10.
2/10, okay. Okay. And we'll go with 2/10. And now what?
Now I want to take 2/10 and multiply it.
How did you know to multiply?
By 60, because the word of signals multiplication.
Okay, multiplication.
So when I take the percent of a number, I'm converting that percent into a decimal, and I'm multiplying by the remaining value.
Okay. Now what do we do?
So we're doing 60.
Does it matter which one goes on the top or the bottom?
It does not matter.
Do you have a preference?
We can go with the 60.
60.
Times 2/10. And we multiply that out. We're doing 2 times 0, which is 0. 2 times 6, which is 12. And the next row, we have zeros.
Do we need to do all the zeros?
We don't need the zeros, but we can put them on in there.
Okay, we'll put them in then. Okay, now the first 0 is marking the place value to let us know.
Which takes the place of the 2.
Right, so we're moving over one space. So 0 times 0 is 0. 0 times 6 is...
Also 0.
Also 0. So now...
We add.
Add. And we can go digit by digit, but we do know that anything plus 0 is that exact same thing. That is called our addition identity property.
Identity property.
The identity property of addition. Okay, now what?
Okay, now our decimal currently is after the 0. So what we want to do is move our decimal point.
Okay, how do you know where to move it?
One place to the left, because we have one decimal place in our problem. So we want to move our decimal one place to the left, from right to left. Our decimal's here. Right now it's in between the 12. Right now it's in between the 2 and the 0. So our final answer is 12.
Okay, and if you'll notice, we came up with the exact same answer using our model method and our multiplication method.
So your method works, the model method, the multiplication method works just the same. We both produce a final result of 12, which is 20% of 60.
And so you can really think about this as 2 times 6 to help us get an estimate of what this is going to be.
That is correct.
To help us out. And so notice that when you're finding the percent of a number, you can use the model method or the multiplication method, whichever makes more sense for you. And depending on the amount of time that you have, which one will be quicker for you. So this helps you with your mental math and your reasoning to get an idea, and this will you can multiply out.
The multiplication serves as a check to confirm your answer.
Okay. And so we were working with percents at 6th grade.
Okay.
Anything in particular you're working with?
Currently, we are working on operations with integers.
Operations with integers.
So that's adding integers, subtracting integers, multiplying integers, as well as dividing integers.
Okay. Operations with integers. You know, that seems to give a lot of students a lot of difficulty remembering, do I keep change? Do I flip? Do I add? Do I subtract?
The rules are very confusing to the students depending on what operation we are dealing with. One thing I have my students jot down with operations with integers is SS plus
SS plus?
DS minus.
DS minus.
Now, when we are adding integers, this can be read as same signs add.
Same signs add. Okay.
Different signs subtract.
Oh. Okay, can you show me exactly how that works?
For example, if I have, let's say we have negative 20 plus negative 15. Now, the first thing I want to identify is whether my integers have the same sign or different signs. Looking at this particular example, both the 20 and the 15 are negative, therefore their signs are the same, and in evaluating that expression, I would add 20 and 15 to give me 35. Now, since both integers that I was adding were negative, I know my final result has to be negative, because a negative plus a negative will always equal a negative.
Oh.
So that's a same sign example for adding integers.
Okay, and we know that if there was no sign at all, that would be considered a positive integer, and we would just add regularly, and that would be a positive 35. Well, what happens?
35.
What happens if the signs are different? Does it matter? What if I wanted that one to stay negative and this one to stay positive?
Okay, well now we're using a different rule now. Now the signs are different, so now we want to subtract their absolute values. The absolute value of a number is its distance from 0 on a number line. So I want to subtract the absolute value, so I'm doing 20 minus 15. Okay, when I find that difference, I get 5. Now I need to determine the sign of my 5, whether it's going to stay positive or negative. And I want to look at the absolute value of both of my integers. The absolute value of negative 20 is 20. The absolute value of 15 is 15. So the negative integer in this case has the greater absolute value. Therefore, my 5 is negative. Now, conversely, if we had 20 plus a negative 15, we will still subtract because the signs are different. However, now the positive integer has the greater absolute value. So for this particular example, the 5 would be positive.
Okay. Oh, so that helped me out with my operations with integers when I'm adding SS plus DS minus. Mr. Belton, when you're doing math, you're having so much fun.
Time
Where
flies.
did the time go? Guess what? We will be right here, so if you'll join us on the other side of the break.
Hi, my name is Jennifer Greer, and I'm here for today's email corner of the day. Today I will show you how to do elapsed time. How can you calculate elapsed time? Here are two clocks. One shows when the party started at 10:10. The other shows when it ended, which is 12:45. First, count the hours. Start at 10:10, 11:10, 12:10. That's 2 hours. Next, count the minutes. 12 start at 12:10, 12:15, 12:20, 12:25, 12:30, 12:35, 12:40, 12:45. That's 35 minutes. Finally, put it all together. 2 hours and 35 minutes. Thanks for joining me for today's email corner today.
There is a country in Europe, Iceland, which has been called the perfect eco-island because it is a place of clean air, fresh water, and natural beauty. Reykjavik, the capital city, radiates pure energy and a thriving culture. Geothermal steam heats homes and pools throughout the city. Iceland offers many opportunities to get re-energized. This is Iceland. Luminous, captivating, unforgettable, beautiful. Come see for yourself.
Many good things are easy to spot, even in black and white. A maple leaf, birds in flight, our trees in summer. But there's one bad thing that's also easy to spot because it is black and white. The Asian longhorn beetle. This insect is killing our trees, but with your help, we can defeat it. It's as simple as black and white. Look for the beetle, and if you spot it, report it at beetlebusters.info.
You can never know which pool safety step will save a life. Until it does. No matter how safe you feel, adding multiple safety steps can mean the difference between a close call and a call to 911. Simple steps save lives. To learn some new ones, visit poolsafely.gov.
And welcome back to your Telly Award-winning math homework hotline. I am Mrs. Davis here with
Mr. Belton. Welcome back.
And we are here to help you with any math homework questions that you might be having. You can give us a call right now. Guess what? There's no waiting in line. If you call right now, you will be the first caller of the second half of the show. We really appreciate all of the students that are tuning in from all across the county. The number is 301-772-0080. So I'm challenging all of the 6th through algebra students, if you're having any math homework questions that you need a little bit of help on as you prepare for FAST, or you just finished FAST and you feel like you got confused or something's coming up, Call us right now. And in addition, you can challenge yourself with the 24 challenge. Please jot these down. Card A, 8411. Card B,
6682.
Card C, 6256.
And card D, 7352.
And we did have Kyrie, who called us in the first half of the show, that has already met the challenge with D. But the great thing about 24 challenge, there's usually more than one solution. And we have a caller for the second half of the show. Carla, are you there? Caller, are you there?
Yes.
Hello. Welcome to Count on Us. Can you give us your name and the school you go to? What is your name, please?
Tamara Williams.
Hello, Tamara Williams. Welcome to Count on Us. And can you tell us which school you attend?
Stephen Decatur.
Stephen Decatur.
Woo! In the house. Stephen Decatur making that telephone ring, ring, ring. Tamara, and can you tell us your math teacher, please?
Mrs. Davis.
Miss Davis, another ring.
All right.
Stephen Decatur's in the house.
Miss Davis and Stephen Decatur is representing. Thank you so much for your call this afternoon, Tamara. And what can we help you with?
40% of 400.
40% of 400.
One of your percent of a number questions, Miss Davis.
All right. Well, Tamara, would you like to use the multiplication method or the model method for helping out with this problem?
The multiplication method.
Okay, multiplication method.
The multiplication method. Okay, so Mr. Belton is going to help you out. I'm going to be the writer. So we want to find 40% of 400. Okay. Now, what exactly do you mean by multiplication method? How does that work?
You have to turn the percent into a decimal.
Okay. What's 40% as a decimal, Tamara?
It's 40 hundredths.
40 hundredths. Very good.
Love that math language.
Now, what do we do with 40 hundredths now that we have it in decimal form?
You're supposed to put 400.
Okay.
Well, you multiply the of means
The of signals multiplication. Very good. Okay, now, what do we do next? And we have it set up?
You have to put 400 over top of 40.
Like this?
Yes.
Okay, are you watching the show, Tamara?
Yes.
Okay. Now, what's the next step?
0 times 0 equals 0.
0 times 0, 0.
And
0
then
times
the
0 again,
times
0.
equals 0.
And 0 times 4
equals 0.
equals 0. Now, before we do any multiplication on the next row, what do we have to place?
You have to place a 0 under the first 0.
We have to place a 0 under the first 0 before we multiply. Now we do what?
Now we multiply 4 times 0, which is 0.
4 times 0, which is 0.
Then 4 times 0 equals 0 again.
4 times 0 again, which is also 0. And lastly?
And then 4 times 4 equals 16.
4 times 4 is 16. Okay, Tamara.
And then I think you have to add them together.
You are correct. The next step is to add. We have zeros plus 0, which is 0.
0 plus 0 equals 0. And then 16 plus 0 equals 6.
16 plus 0 equals 6. Now what do we have to do, Tamara? There's one last step before we are complete.
Then you have to make the 16,000 into 160.
160. How do we do that? Because we have to, there's something that we have to move. What do we have to move?
You have to move the decimal down. You have to move the decimal over 2 times.
In what direction?
The
I'm sorry?
Left.
Left. Very good. When we move our decimal twice to the left, we end up with 160. So 40% of 400 is
160.
160. Very good, Tamara. Very good.
All right, Tamara. Now, Tamara, did you want to try one of the Challenge 24 cards as well?
Yes.
Okay.
Right. Excellent.
Tamara, we have another caller, so if you would just jot down.
Did you already have a solution for us? Or did you want to work it out?
I wanted to work it out.
Okay, so you want to jot it down and give us a quick call back? Your name is going into the apple, so you're definitely going to have to stay tuned to see at the end of the show if you are indeed one of our winners of a fabulous prize. So can I ask you to give us a quick call back?
Okay.
What do you know, Tamara, before you go, do you know which card you're trying?
No.
Okay, so do you want to do card A, which is 8411?
B is 8662.
C
I'll
is...
try A.
Okay, so go ahead and jot that down, 8411. And we will be right here waiting, so give us a quick call back.
Okay.
After we help Stephanie. Stephanie, are you there? Stephanie?
Yes.
Hi, Stephanie. How are you today?
I'm good.
Welcome to Count on Us. Which school are you calling from?
John Bain.
John Bain.
John Bain.
All right. Is this your first time calling Count on Us?
Yes.
Okay. A brand new caller. Welcome, Stephanie.
New caller. Welcome from John Bain. What grade are you, Stephanie?
Oh, I'm in the 6th.
Sixth grade. Okay, Stephanie.
Excellent.
How can we help you this evening?
I needed help on an algebra problem.
You needed help on an
Guess
algebra
what,
problem.
Stephanie? That is what we're here for. You can count on us.
You called the right place. How can we
Okay.
help you? What's your question?
Oh, okay. The problem is 7x minus 2 equals 4x plus 3.
7x minus 2 equals 4x.
Was it plus 3?
Plus 3.
Okay.
All right. This is considered an algebra problem because we have variables in the problem. Now, which of our terms are considered our variable terms? Which terms are variable terms?
Variable terms are 7x and 4x.
7x and 4x. Very good.
Okay. Now, what do you know about solving? This is called an algebra problem where we have variables on both sides of the equal sign. What do you know about solving an algebra problem such as this?
You know when it's like a subtraction sign, you add the problem to the same... I forgot the name.
Okay. So if we're trying to figure out 7 times what number minus 2 is equal to 4 times that same number plus 3. So we're trying to figure out this unknown number, our variable. What can we put in the place of our variable? And for solving this, we want to get all of our variable terms on one side, and we want to get all of our constants or our non-variable terms on the other side. Now, which way would you like for these variables to go? Would you like all your variables on the left or the right?
Left.
The
Okay,
left.
we're going to move them to the left. Now, how can we do that? So here we have, how can we get this 4x off of this side and over to this side? Do you know how to start that process, or do you need some help? Some hints?
You use 4x and you subtract it from 7x.
Okay, 4x on this side, and to keep it balanced, we're going to do the exact same thing on this side. So we're going to subtract 4x here. Okay, and I'm doing this going down vertically. So 4x minus 4x gives me
0.
0.
So we can cancel that out.
0. We cancel that out with a nice 0. And 7x minus 4x gives me how much?
3x.
3x. And we haven't used our subtract 2. We must keep our equal sign, and this is plus 3 or just 3. Okay? So 3x minus 2 equals 3. Now we want to get our variable term all by itself. So what would be our next thing that we need to get rid of? I like to think of my variable term as having some sort of chicken pox. I'm putting it in a box and I'm trying to get everything away from it. So how can I get rid of this subtract 2 or negative 2?
You add 2 to 3.
We're going to add 2 to both sides, so not just to the 3.
You want to do it to both sides.
And notice that I have my equal sign here, so I'm keeping everything balanced.
That keeps your equation balanced. That is correct. Performing the same operation on both sides.
So if I can think of this as negative 2 and positive 2, or subtracting 2, then adding 2. That's going to give me what?
0.
And that cancels out. And here, what is 3 plus 2?
5.
It equals 5. And so now I have my variable term, 3x equals 5. I haven't quite gotten my variable by itself. I'm multiplying times 3. So what would be my opposite operation?
Negative.
Right now, 3 times some number is equal to 5. What would be my opposite of multiplying?
Dividing.
Excellent. So I'm going to divide both sides by...
What number, Stephanie?
3.
3 or 5?
Both sides.
Divide both sides by what number?
3, 5, or 8?
3.
3. And the way that I know that is whatever is right here next to my variable called the coefficient, that is what I divide by. So you won't get tripped up if you circle what's next to your variable, your coefficient, and that will be what I divide by. All right, so 3 divided by 3 is how much?
Is 1.
1, absolutely. So if I have just 1x, it's just equal to x. And I have 5 divided by 3, which is just 5/3. And when I'm working with algebra, I don't have to simplify this to a mixed number or a decimal, but I do want to put it back in the equation to see if it checks, to make sure. Mr. Belton, we're good?
Yes, x is equal to 5/3.
Okay, so I'm just going to very quickly substitute back in my 5/3 and see if I come up with equivalent expression, making sure that these are equal. Okay, so here I have 7/35
over 3
minus 2. Is that equal to 20 over 3 plus 3?
Okay, now we can write this 2 as 6 over 3, since we already have a denominator of 3. So the left side is equal to 29 over 3. Now the right side, since we again have a denominator of 3, we want to write the whole number 3 as 9/3, or 9 over 3. And we see that the right side is also equal to 29 over 3. So what we have done is actually checked our answer to make sure that the left side of the equation is actually equal to the right side.
And so in this equation, x equals 29/3. All right. I'm sorry. I apologize. When we checked, our final answer both came out to 29/3, but our actual value of x is 5/3. Stephanie, did that help out?
Yes.
All right. Thank you so much for your call, Stephanie. And we do have a couple of other callers, so if you want to do a challenge, we'll ask that you give us a quick call back. Is that okay?
Okay.
All right. And please tell all of your friends at John Bain that they can always count on us for their math homework help. And we do have another caller. Caller, are you there? Is this Samuel? Samuel, are you there?
Yes, ma'am.
Hi, Samuel. Welcome to Count on Us. What school are you calling from?
Gwen Park Middle.
Gwen Park Middle School.
All right. Samuel, your voice sounds very familiar. Are you a first-time caller?
No, ma'am.
All right. Well, welcome back. We really appreciate all of our frequent fans of Count on Us. And what are you working with, Samuel?
I'm working with adding integers.
Adding integers. All right. Love your positive attitude and your pleasant personality and manners.
What's your question, Sam? How can we help you?
I'm on question 30 doing negative 13.
Negative 13.
Plus 27.
Plus 27.
Oh,
all right. Now.
I also have something else.
Oh, okay.
Plus negative 18.
Plus negative 18.
So this is a multiple. So we have 3 integers that we're adding, not just 2. Is that correct?
Yes, ma'am.
Is that it?
Right.
Is that it, Sam?
Yes, Mr. Belton.
Okay.
All right.
Now, Sam, the first thing we want to do is work with the negative 13 plus 27. We want to break this problem up into 2 problems, so to speak. So let's take care of negative 13 plus 27 first. Are those signs the same or different signs?
Different signs.
Different signs, we do what?
Keep change.
Not keep change. That's for subtracting integers. Right now we have an addition problem. Different signs, we...
I can't see you divide by both, you subtract by both sides.
Different signs, we subtract. So we're going to take 27 minus 13. And that's equal to?
14.
14. Now, Sam, I need you to help me out. I kind of forgot. Is the 14 going to be positive or negative?
Positive.
Why? That is correct. Why is the 14 positive?
Because positive 27 is greater than negative 13.
In terms of its absolute value. So the 14 is positive. So now we have 14 plus negative 18. Again, are the signs the same or different?
Different.
Different signs, we?
Subtract.
Subtract. So we're doing 18 minus 14. And we get?
4.
4. Now, which integer has the greater absolute value now, Sam? The negative integer or the positive integer?
The negative integer.
So our 4 should be?
Negative.
Negative. So our final answer, negative 13 plus 27 plus a negative 18 equals negative 4. Does that help you out, Sam?
Yes, Mr. Butler.
Okay, so you remember instead of keep change, which goes with subtraction, if we're following Mr. Belton's example, SD minus, which means subtract.
Different signs, we subtract. Good job, Sam.
All right, thank you so much for your call. And if you'd like to do a challenge, we're going to ask you to give us a quick call back. We do have time for one more caller. Is this Kennedy?
Yes.
Hello, Kennedy. What school are you calling from, Kennedy?
James Madison.
James Madison.
Kennedy, you go to James Madison. Well, welcome to Count on Us. I'm going to ask, is this your first time calling Count on Us?
Yes.
All right. Kennedy!
Another first-time caller.
We really appreciate you calling in this afternoon. And your name is going into the apple just for calling the show. And please stay tuned to the end of the show for a chance of a fabulous prize. All right, Kennedy, how can we help you this afternoon?
I have a word problem.
A word problem. And you know, in mathematics, most of the problems you encounter will be in the form of words. And we have about 5 minutes remaining in the show, so we're going to try to help you very quickly. So can you read the problem?
Mm-hmm.
Okay.
38 shoes are in the closet.
Oh, this sound. Now, Kennedy, do you have 38 shoes in your closet?
Yes.
Oh, wow. So you like shoes. Okay, so I'm going to abbreviate so we can... 38 shoes in the closet. And what's happening with those shoes?
12 shoes are on the floor.
Oh, this sounds like somebody's room I know. 12 shoes on the floor.
19 hats are on the shelf.
19 what?
Hats.
19 hats.
Okay. On the shelf? Okay. And what else?
How many shoes are there in all?
Oh, how many shoes are there in all? Okay, Kennedy, I really think we can help you with this problem. And the first thing we have to recognize is the question that's being asked. We're being asked, how many shoes are there in all? Okay, so if we want to know how many shoes there are in all, we're going to go into our word problem and find out information about shoes. Well, we know that 38 of them are in the closet, 12 of them are on the floor, 19 hats on the shelf has nothing to do with shoes, so I can just not even think about that at all. I can draw a line through it or just ignore it altogether. So all I'm going to do is concentrate on these shoes. We have 38 in the closet, 12 on the floor, and let's see if we can find out how many in all by combining together or adding. Can you help me out? What is 8 plus 2? 10. So I'm going to put down 0 and I'm going to regroup. 1. 1 plus 3 is?
4.
4 plus 1 is?
5.
So,
how many
shoes do we have in all?
50.
50 shoes.
Very good,
wow.
Kennedy. Good job.
That is a lot of shoes, Kennedy. Okay, did that help you out, Kennedy?
Yes.
All right.
You have any more questions for us, Kennedy?
No.
No?
Okay.
Before you go, would you like to try a challenge, a 24 challenge?
Yes.
Okay, Kennedy, guess what? Your name went into the apple, so please stay tuned to see if you are indeed a winner at the end of the show of a fabulous prize. Now, Kennedy, I have a quick question. Do you know anything about Springwater Lane? Oh, she's gone. Okay. Well, I would think was there a challenge?
No, she didn't try the challenge. Okay. Okay.
Okay, so we have had some fabulous callers here today from a variety of schools. It is our pleasure to help you out with your math homework. I'm not quite sure. Is it time to pull a name, or do we have time to do a challenge, or?
Do we have time? Do we have any? We don't have any callers.
Okay. Well, it has been our pleasure helping you with your math homework this afternoon, working with operations with integers.
Percent of a number.
Percent of a number, some equations.
Word problems.
Word problems, just a variety of things.
Miss Davis, do you want to do the honors? Okay.
Okay.
Would you like
oh. So we'll go ahead. We hope all of our callers tuned in and find out if they are indeed a winner. So if you completed a question and you did a 24 challenge, your name has gone in.
Not once, but twice.
But twice, and so that increases the probability of you being a winner. So, Mr. Belton, I would be happy to shake it up. Shake, shake, shake. We appreciate all of the callers, and
we have
a winner from
Samuel from Gwen Park Middle School.
Samuel from Gwen Park Middle School, representing Gwen Park Middle School.